All right, let's look at electrolysis. Electrolysis is the process of passing an electric current through a mixture that causes it to break down. So electrolysis with a current here, if we consider current, we are looking at units of amps, and we really need to understand that an amp, in terms of its units, is a coulomb per second. So we can take and pass current, coulombs per second, so it's charge per second, to put it through a mixture to do what kind of we ever need to do with that mixture. One of the things that we use electrolysis for is to break water down to hydrogen and oxygen. We can also commonly use it for electroplating, which is to take with electricity, put a layer or a plate of a metal on top of some other metal. We can also use it to generate things like chlorine in industry. So let's look at an example of electroplating. If we want to take water, we can take water and we can decompose it into its separate components of oxygen and hydrogen gas. We use electrolysis, meaning we're putting electrons in for this to occur. So we use some acid in here to get a nice number of ions in solution. It really doesn't need to be in there in terms of the reaction, but what happens as we break it apart and we take our water is we're going to break it into H2 plus O2. And we can collect these two separately, and we can do that separately because one of these reactions will occur at the anode and one of them will occur at the cathode. It's a great way to get ourselves some nice hydrogen gas. So electroplating. Electroplating uses electrolysis, so we're adding electricity to a reaction, causing a metal or a layer of metal to plate out, to coat itself onto the surface of something. So we start out with the metal to be plated, what we want to take and put as our surface, in solution as an ion, and then we need to add some current to this. We need to put some amperage in, or coulombs per second. We also need to do some other things. We need to know the half reaction to determine how many moles of electrons the reaction takes to occur. We're going to need Faraday's constant. We're going to need the molar mass of the stuff that we are going to want to plate out, and we go from there. How might this work? Well, if you wanted to take and put a layer of silver onto a spoon that is not made of silver, if we put electrons in, we can take and force the electrons to build up on the outside of this spoon. And when that happens, the silver that is sitting here in the solution as a charged metal will stick to the electrons, and you will get a layer of silver on the outside. This is electroplating. Now, in order to figure out how much stuff we can make if we do some electroplating, we need some information. We need to remember that an amp is a coulomb per second. We need to remember Faraday's constant is 96,485 coulombs per mole of electrons. We need to know how many electrons are going to be transferred, so we need to look at the metal being plated out. We've got a solution of calcium chloride, and we're trying to make calcium as a solid. Chloride here is going to be inert, so we're going to take our calcium and we're going to add 2 electrons to make Ca as a solid. So our number of moles of electrons here is going to be 2. And we're going to need the molar mass of calcium. And the molar mass of calcium is 40.1 grams per mole. So where do we start? We start with the 1.5 hours. It's the only fixed value in this conversion here. Everything else, the conversion factor. So way back to the beginning of Chem 111, 1.5 hours. We know there's 60 minutes per hour. We know there's 60 seconds per minute. We know we're going to put seconds on the bottom. We've got to figure out what else we know. Well, we know what an amp is. An amp is going to be coulombs per second, so we're going to have 0.452 coulombs per second. Now we're going to put coulombs on the bottom. Well, we got Faraday's constant, 96,485 coulombs per mole of electrons. Now we're going to have to cancel out our mole of electrons. Well, we know there's 1 mole of calcium for every 2 moles of electrons. And the last step here is there's 40.1 grams of calcium per mole of calcium. That is going to finish up our problem. And when we're done, with this entire question, we're going to get a surprisingly small value of 0.507 grams of calcium electroplated out of this solution. So let's do one more. We want to know how long to plate out 1 gram of nickel. So we're going to start out with 1 gram of nickel, and we're going to have to work through what we know to get the time. We know there's 1 mole of nickel. Off of our periodic table, our molar mass is 58.7 grams. We know our solution is nickel sulfate, so we have 2 moles of nickel, or excuse me, 2 moles of electrons needed for every 1 mole of nickel that is electroplated out, because Ni 2 plus 2 electrons goes into Ni. So we have 2 moles of electrons for every 1 mole of nickel. Now we know that Faraday's constant is 96,485 coulombs per mole of electrons. And we're just going to keep going like this. We know that an amp is a coulomb per second. So we need coulombs on the bottom. So we have 25 amps, so it's 25 coulombs per second. That's going to give us seconds. They want to know minutes. So we know that there are going to be 1 minute for every 60 seconds. So we work the math out, cross out our units, and realize that we're going to have 2.19 minutes of time with an amperage of 25 amps. We'll plate out 1.0 grams of nickel from a solution of nickel sulfate.